Hi, I'm Ayse. I'm a professor here at BU, and I'm going to talk about our AI for CloudOps project. So this is a large project funded by the collaboratory, started last year, and I lead this project along with my colleagues GENI and Ellen Liu. And we have an excellent team of PhD students, some of whom will be presenting posters in the poster session today, so please do check that out. And if you're around tomorrow, we'll talk some of the more forward-looking open problems that we would like to address in the future, so we have a talk tomorrow as well. I can't see my slides here. Right. Okay. I guess that's why people were using this microphone. Does it work? Yeah. So, cloud is a layered complex software which is deployed on heterogeneous software, and the overall hardware-software environment is diverse, heterogeneous. Software is deployed on a daily basis and updated multiple times a day often. So all this lively, diverse environment creates problems when you want to improve efficiency or diagnose problems fast. So secure and resilient cloud is a must for all businesses that are running on the cloud. But the existing practices are fragile often, so they often rely heavily on manual expertise, somebody who knows everything to come in and write a script to debug a problem. Or, we end up spending lots of time and money in figuring out problems, and sometimes we just cannot figure out problems. So at the same time, in tandem with all of this, one thing that's worth noting is that AI, or broadly machine learning, has reached a stage where it's everywhere. Like we saw in one of the other talks earlier that AI is taking over many compute cycles today, right? But when we look into how computer systems are managed, we don't see much impact of that yet, right? So there's some of machine learning used, especially in resource management, but there's this gap between where AI is today versus how computer systems are managed, which heavily relies on expert involvement today. So our goal in this project is to bridge this gap and create this rich, useful, practical set of methods, ops functionality to the cloud in a coherent, unified way as much as possible. So we want to provide this end-to-end in a way that starts at the development stage. So while people are coding, they should already gain some insight into whether they are doing something wrong. Like if you type and include a vulnerable package, we should be able to detect that and warn you before you do anything with that code further. In deployment stage, and when the software is being installed, again, we can have machine learning engines essentially determine if your package actually involves some other thing that wasn't updated, or that's vulnerable, that's known to be vulnerable. And finally, at runtime, we'd like to make sure we identify rapidly performance problems, bugs and the like, and then resolve them as soon as possible before they create bigger problems. So this is how we envision our real-time quality assurance framework to look like. So you have a Jupyter notebook, for instance. You can have a different environment as well. And then while you are coding, while you are deploying, and then when you are running things, you can see these warnings. For instance, the yellow bar over there shows a problem about an outdated module you just included in your code. The orange one is basically pointing out to a known SQL injection vulnerability that comes with a package. The pink one is showing a performance problem. You change something in your code, now your code takes much longer, and here's the profile associated with that piece of code. So we'd like this to happen in a really easy-to-use way for the developers as well as for the administrators. So I'll show you a few things briefly, like what's happening in this project, how we accomplish this vision of AI for CloudOps. And like I said, tomorrow we'll talk more about the forward-looking problems. So one way that we look into the development side of things is that while you are coding, this engine called Pirate is going to come in and mark up anything that is known to have a vulnerability. And we would like to develop this in a general enough way that you don't have to train a separate engine for every single problem, but basically machine learning gathers a lot of data from known databases, and then in the back end accomplishes this, and while you are coding, you can already get warnings about what you are not supposed to include in the code. In deployment stage, our machine learning empowered engine Taxi, for instance, can create footprints out of the files that your software is installing, and then compare these footprints in an efficient and really fast way to known problems or known vulnerable. It could be buggy code, it could be vulnerable code, again in known databases. So in this way, when you install something, you wanted to install Keras, but it actually came with a known vulnerable version of TensorFlow, which you didn't have an idea about, so it's going to mark this for you and show you right away. And then finally, at runtime, analytics is going to provide you with the capability to diagnose problems. Problems will happen inevitably, but can we detect and diagnose them and localize them fast? So our distributed tracing method uses online learning to determine the most efficient traces that are required for a given problem as fast as possible, with using as little storage as possible. So that's one line of research that we have some nice outcomes that you can see in the poster session. And then a big part of runtime activities is to actually look at data, right? So without data, we wouldn't be able to learn anything or diagnose anything. And part of the problem is this data often has privacy concerns. Like, you want to get data from your company, from your institution. You may not be willing to expose everything about your location, about your IP, about your other sensitive information. So we have methods that take the actual data and then apply methods on it, again, actually partially based on machine learning, and then keep the fidelity of the data while providing differential privacy properties on this data. So, of the Heidi.
Hi, so my part of this project is to try to figure out how to take the data that we have in our operating environment in the MOC and in NERC and make it available to the AI Ops project, and how to support the work that they're doing and make it part of our operations environment. So there were two main challenges to that. One is to collect the right data, and the other is to provide access to the right data. So you can think of it as if there's a big field of blueberries out there, and I've gone and collected all of these, but I don't know who wants blueberries, and I don't know which blueberries they want, or if they all want pie. And so I'm trying to figure out from the people who are here today and people who are listening online, tell us what kind of data will make your research go better or make your operations go better, so that we can organize that and start iterating with Ayse's team and with the ops team to make that possible to use in the builds that we're doing in Mass Open Cloud and in NERC. So just a really quick list. You probably can think yourselves of all the kinds of data that we might have, because most of you have run clusters before. One thing to point out is that we have multiple clusters and we have multiple different infrastructures, as you probably saw if you were looking at the slides that Aran was going through earlier. And so the tools that we need to be able to handle the idea of there being multiple clusters and there being multiple ways of pulling data. Instead of just going and pulling APIs, which is a perfectly good way to gather some data, we actually have tools that are already in the operations environment that are pulling, storing, archiving, rolling over the data, and there's in particular a tool called the automated cluster management, which we're using a lot of in operations. Chris Tate, who's the man in the red hat, and Lars, who I can't see at the moment, but he was sitting at the same table, can give you all the details on how that's implemented. There's also a link at the bottom of these slides about how that's implemented if you want to hear more about what we've got. One other thing to mention is that there is such a thing as events in our operations. So it is possible to pick things out either through an AI ops model or through normal collection and correlation of data and cause that to generate alerts to people who might care. So not just the single developer, but a larger group of people who might be working on a project, or a larger group of operators and admins who are supporting an infrastructure. So we're interested in seeing how we can adapt that. Going to the second problem of access, Ayse already touched on this somewhat, which is we need to provide access, but we also need to protect data privacy. for the users and for data that might be part of projects and applications that are in our different infrastructures. So we want to provide as much access as possible. Right now, we're focusing on the projects that are part of the MOC and the Red Hat Collaboratory, but if there are other projects out there who want to become involved in this effort, we'd love to hear from you. We are also considering the possibility of developing data sets that could become actual benchmarks and training data sets for the wider community to use. So if there's a set of data that we record that shows certain operational issues occurring, and somebody wants to get access to all that to use as training for a new model, we hope to be able to support that kind of an idea. And last of all, just want to point out that because this is a live infrastructure and we're changing versions and we're upgrading and adding new software all the time, that means that the data is changing over time and people's experiments tend to run for a long period. So we have to deal with the issue of how to reproducibly collect data and how to store all of the associated information about what was running in the environment at the time, so that when you go to publish, there's enough background on what was happening with your data. So we're working on this with Ayse's group and with operations, and feel free to get us in the box or talk to us in the hallways if you're interested in more info. Thanks.